Hello, everybody. No, the last name is difficult, so it's Rajagopal. Ananda Rajagopal from Foundry Networks. Hopefully, you've heard of Foundry. If you have, if you have not, do come over to the Beer and Gear event. If not, if you already heard of it, that's fine too. Please come over to what we often say is one of the best networking events during NANOC, the Beer and Gear part. So my topic for today is multi-provider Ethernet service delivery. And in the course of talking to several providers and also several businesses who are contemplating purchasing Ethernet service delivery, this seemed to be kind of a topic which caught the interest of many folks, which is the reason why I'm talking about it today. So first of all, in terms of what I plan to cover, hopefully this will take about 20-25 minutes maybe, and since we are ahead of schedule, we'll have some good time for Q&A towards the end. So what I plan to cover is what exactly is multi-provider Ethernet service delivery, the typical way in which it's done today, a proposed model, also comparison with other potential approaches, benefits, challenges, and then open it up for interactive discussion towards the end. It's always a good question to ask before talking about any problem if there's really a need for it. So the major drivers for large-scale Ethernet service deployment across multi-provider networks, which is really what multi-provider Ethernet service delivery is, there are really many drivers for it today. Well, first and foremost being the increasing globalization of customers who purchase such services. Number two being the fact that the reality is that there's a limited reach of providers, and there are lots of local providers that are more common than what I would say is global titans. There's clearly need to simplify inter-provider handoffs, and oftentimes business continuity reasons might require enterprises to connect critical sites to a second provider. Another thing which is important, I guess, in the wake of the Dow hitting a new record last week is the fact that integration of networks after acquisition is also something wherein multi-provider Ethernet service delivery comes to play. So I like to think of ourselves as being in the Dow 12,000 era, at the risk of sounding like an irrational at the risk of sounding as somebody suffering from irrational exuberance. And last but not the least, multi-provider service delivery is or was common in the frame relay and ATM deployment days, and so having a similar expectation from Ethernet service delivery is something that we can expect customers to have. So reset to what is done today. So predominantly it's a point-to-point service. In the terminology of Metro Ethernet Forum, it's a E-line service. And multi-point services, or E-LAN service as MEF likes to call it, are mainly delivered as transparent LAN services. We're all aware about the limitations in terms of scalability there, the complexity in management, and it's fair to say that VPLS is now beginning to pick up in terms of offering this service delivery. But that said, it's a fast-growing market, even though it's small today compared to the alternatives. And the majority of the services continue to be leased line, frame relay, or ATM. Perhaps the two big challenges continue to be the geographic coverage that continues to be the big hindrance in terms of increasing adoption to the Ethernet service. And if you were to break it down into why this is such a big problem, I would call it as one, reach of fiber, and B, reach of the provider. And this presentation talks specifically more in terms of addressing the reach of the provider issues and how we as a community can cooperate to have inter-provider or multi-provider Ethernet services. So the proposed model here is fairly simple. Assume that you've got two provider networks, and there's no kind of imposement in terms of how Ethernet service delivery is done within that network. The idea is to use a simplified external NNI or a network-network interface between the provider boundaries. And the model proposes using the recently standardized IEEE 822.1ad. So essentially what you have here is a case wherein you've got, for example, customer A, which got some sites wherein that could easily be connected to provider 1's network, and maybe it got some sites which cannot be addressed directly by provider 1, but can be addressed by provider 2. So provider 1 and 2 need to kind of maybe have an agreement so that they could help deliver an Ethernet service, either point-to-point or point-to-multipoint, between all the sites that connect customer A. In this example, the diagram talks about using VPLS within the provider 1 network. There really isn't any imposement in this model as to what the technology should be used within a provider's network. So the model in words, each provider is responsible for his or her own network and for what I call as simple handoffs to the adjacent provider's network. And as mentioned before, each provider independently chooses the appropriate technology to transport Ethernet service over that domain. So you could be using VPLS, you could be using just Ethernet over MPLS, we're just using point-to-point VPNs. If for some reason there is a resistance to move to MPLS-based networks and you're fine with having a pure layer 2 network using .1AH or the emerging .1AH, that's fine too. Or if somebody wants to use L2TP v3 within a provider's network and have Ethernet over L2TP, that's perfectly fine too. But the goal here is that the handoffs to the other providers are done using 822.1ad as the ENNI. In a minute, I'll come to a quick overview of .1ad and how it applies to this model. The .1ad also has provisions for handling the service VID translation, which is useful in terms of interfacing with another provider's network. And secondly, you could also be using the combination of SVID and CVID and map it to the partner's E-line or ELAN segment, which is also possible. The boundary nodes are the ones which really sit at the border of your network or you as a provider's network, and which also talks to the partner network. And the role that it plays is essentially incoming packets which come from the neighboring provider's network, because they're coming in .1ad form, that be mapped to the appropriate tunnel in the provider domain. Okay, so for instance, if you're using VPLS, you're mapping .1ad into the VPLS instance. If you're using .1AH, then maybe you'd be mapping the .1ad frames to .1AH. Conversely, for packets going out to the neighboring provider network, you'd be terminating the local tunnel and then encapsulating the packet in .1ad and sending it to the neighboring provider. So in terms of the .1ad frame format, from just looking at it, it kind of appears as if it's really very similar to Q&Q, but really it's, although there are encapsulation related similarities, .1ad is fundamentally quite different from that. But some of the things which are useful from the point of view of the NNI is that there is a discard eligible indicator which is there in the outer or the service tag or the service VLAN ID, and the C VLAN ID or the C tag format is fairly similar to the VLAN encapsulation as we know today. And what used to be known as 822.1p is encoded as the priority code point or PCP. So in terms of traffic engineering and QoS, again the approach is to take a hierarchical view of this. So each provider network determines the best path within that network, and it's optimized within each domain. What's key here is that the inter-provider boundaries, we've got the mappings between EXP to .1AD PCP mappings. Again, assuming here that the first provider uses MPLS within that network. You're really doing this at the service instance level, because the inner tag, or so to say, as the customer frames, are itself being transported transparently without any modification of that. Resiliency is often a big concern, or redundancy. And the resiliency mechanisms which are used by each provider within his domain of influence or within his network is independent of what other providers may be using. So again, going back to the example of using VPLS, for instance, within a provider's network, you could be using fast readout within that network, and the mechanisms that are being used for redundancy in your partner's network have got no bearing on this. However, at the boundary nodes, you could be using dual homing for the provider-provider interconnect for inter-provider resiliency. In terms of provisioning, what a provider needs to know is the SVID of the partner provider, or something that they could agree upon, and then submit a request to the partner provider, where the partner provider's operations staff would map that SVID CVID instance to the L2 VPN instance that's internal to their network. Now obviously this kind of becomes a little cumbersome if you're handling a lot of instances, so wholesaling often becomes a more appealing alternative. In this case, you do not care about what's the CVID that's being transported, but the SVID really acts as a tunnel that is transported across the provider B's network. If I were to draw a corollary with ATM networks, I would say that this is kind of like ATM VP trunking here. So in this case, the SVLAN bridge functionality of 822.1AD, wherein you really do not have a CVLAN component, and you're just kind of mapping an SVID instance to another, when you're really operating at the SVLAN ID instance level is all that is required. And this may well be simpler to manage based on the traffic patterns that are flowing within the network. And of course, existing provisioning systems used by the provider can continue to be used. As far as troubleshooting is concerned, logically, troubleshooting a reported incident within a provider domain first would be the right thing to do. So the question here is, can I reach the endpoint of this service instance within my provider domain? If yes, then clearly it's something that we have to work with the partner provider. If not, it's something you'd be troubleshooting internally. But within the domain, OEM utilities such as LSP ping or .1AG, etc., can be used to troubleshoot the L2 VPN instance. Something that's more difficult, however, is troubleshooting SLA violations for the end-to-end customer service, because this clearly requires cooperation among the providers. And examples of such violations could be maybe a certain round-trip delay got exceeded, or perhaps there is a simple connectivity loss, or a much more simpler issue of a connectivity loss for an end-to-end service. In terms of comparison with other approaches, I picked two examples here, one being HVPLS and the second being multi-segment pseudo-wire. So if you look at HVPLS with spoke VLL, it expects the different provider networks through which the EVC is delivered all support VPLS, at least, if not full VPLS, at least the spoke part of it. Multi-segment pseudo-wire is clearly something which has been gathering a little more momentum of late at the IETF, but it's fair to say it's still the conceptual stage with little vendor support today. But that said, it's really suitable for very large-scale deployments, and also, more interestingly, facilitates interworking of different pseudo-wire types. In fact, what's really proposed here in this model can be looked at as a subset of multi-segment pseudo-wire that's in the works right now, which goes with the descriptive and short name of inter-provider switching using attachment circuits. In terms of the benefits of this approach, it's a hierarchical solution to offering multi-provider services, with the hierarchy, most importantly, being aligned across organizational boundaries. It uses the technologies that are already standardized today or well known. So .180 was ratified earlier this year, as I mentioned. So this helps avoid vendor lock-in, and for providers who are contemplating to provide such multi-provider service delivery, gives a range of options to choose from. One thing that I find appealing here is that the technology used in provider A's network is independent of what is used in provider B's network, with the exception that the boundary nodes, of course, should be supporting .180. To be sure, there are quite a few challenges, which are probably more at the operational level as opposed to the technology level. First of all is the inter-provider relationships. And by the way, some of these are kind of general challenges, I would guess, in terms of inter-provider service delivery. The first one is, of course, who owns the customer? Is the customer owned by the provider with whom contact was first made? Or maybe you have a policy wherein there is ownership based on geographical regions. So I'm a provider based on the West Coast, and maybe I want to have an agreement with somebody who serves the UK area. And because I've got no interest in having local service in the UK area, maybe anybody who is a customer in the UK area becomes my partner's customers, and anybody else would, in my local area, would be my customers. You could also have revenue sharing arrangements based on any such criteria. Of course, I'd welcome other thoughts in terms of revenue sharing agreements that we could have. The other one is in terms of the customer or the end user ownership related to provisioning. So a logical next step would be, even though it's a pretty significant leap forward, would be to have the provisioning systems of providers be integrated to simplify end-to-end provisioning. And I guess this really is driven by the number of instances of Ethernet services when you'd be having multi-provider segments. Billing and accounting, and as we saw before, SLA guarantees, maintaining that is certainly not trivial. So while negotiating a partnering agreement here, I think it's important that the two providers agree on what is the SLA that we could agree upon, at least for the tunnel. Ditto for troubleshooting and end customer outage. The customer who's purchasing the Ethernet service needs to know who should take responsibility for the resolution. And a simple answer to this would be the provider who sends the bill to the customer, he takes responsibility for this. So that's pretty much what I had. And before we open it up for Q&A, I'd just like to take a small poll. How many of you are contemplating or actually already doing multi-provider Ethernet services today? Great. Thank you. So that's it that I had, and feel free to come over to the microphone and have some questions. Yes, sir.
Excuse me. Keith Mitchell, ISC. I've done quite a lot of this layer 2 inter-provider provisioning in the past, and there's a whole bunch of issues. I think one of the biggest ones is that layer 2 infrastructure is much more fragile than layer 3 IP, and it's very easy for stray layer 2 traffic, particularly if it's non-unicast traffic, in one provider's network to cause operational issues in another provider's across the interconnect. I'd be interested to know if this approach you're proposing has any mechanisms to help prevent and deal with these kind of issues.
Okay, so first of all, just to make it more explicit, what's being proposed here is not to have a layer 2 infrastructure, but the focus is on providing layer 2 service, which means that it could be built on top of a layer 3 infrastructure. So for instance, when we talked about MPLS layer 2 VPNs being used, it's really being built over a layer 3 infrastructure. So it's the handoffs wherein you're really having a layer 2 handoff. Does that help?
Okay, but there's still a layer 2 service being provided end to end, and there's still the possibility of interconnection of different layer 2 infrastructures and layer 2 traffic causing problems.
Right, so that's really something the customer decides, or the end customer decides to purchase as a layer 2 service, right?
Okay.
So, question for you first, and then I'd like to poll the audience. Do you think providers are going to have any concern about broadcast flooding and unknown unicasts going across the wide area?
Right. So I guess it goes back to the question the previous gentleman asked. Absolutely. And I think while planning for a network like this, we've got to have checks in place to make sure that that does not happen. And I think it's fair to say that most equipment in the market today already have those mechanisms in place. I just want to re-emphasize again that the goal here is not to have a layer 2 infrastructure, but only to have a layer 2 service that's being delivered end to end.
But all the current proposals don't address this issue very well. So are you proposing that something needs to be fixed or brought to the standards community to deal with this?
Right. So I think there are already efforts underway, for instance, at the IEEE and IETF in terms of curtailing broadcast storms. Because it's kind of so much futuristic, I think it's hard to talk about that right now without really getting into something which is, I would say, about at least a couple of years from commercial deployment right now.
And you said that the hierarchy will allow a scalable service. Have you received or tried to get any data on the number of Macs that could be supported over this? Or do you suggest a safe deployment is to front end the service with routers?
Right. So I think if you're talking about point-to-point deployments, then there's really no need for doing MAC address learning. The issue comes more in the point of point-to-multipoint services, right? Yes, there are certainly limits there that one should be cognizant about, and the only thing I would say is that it's an important consideration while planning out your network in terms of designing the equipment that needs to be chosen, as well as the way the network is laid out.
Okay. I'd like to hear what the audience says, if anybody's an opinion.
Sure.
Hi. Just a correction on the multi-segment pseudo-wire. And in fact, we implement towards the end of last year, interop with 2 vendors and in deployment right now. And also that is beyond the concept in IETF. As a matter of fact, we address interdomain OEM and a bunch of other stuff already. So whatever you consider as other solutions already working, it's already in deployment. Thank you.
Okay. So to just clarify by conceptual, I meant, it's still at a draft stage, but thank you for the correction. Other comments or questions? Thank you. Thank you.